Hey guys, here's a short video to help you with the free fall worksheet. So we're going to see two new equations here. One for how fast something is going after it's been in free fall for a while. And then the other equation will be to figure out how far something has gone when it's been in free fall for some time. So as you recall, in class today, an object is in free fall if the only force acting on it is gravity. So just gravity, no air resistance, nothing else, just gravity. That's when something is in free fall. Now, we also briefly saw what G is. The lowercase letter G stands for 10 meters per second squared. We covered that in class as well. And that brings us to the equations. Now, I'm going to switch over here to a pad of paper so we can see what we're doing. Let's do this. We'll do a focus again, make sure it all looks good. There we are, very nice. And open that up. Okay, so the first equation is for how fast, and this equation is V equals GT. That's it. Now, what do these stand for? V, as you probably recall, stands for speed or velocity. G, as we said before, is a symbol which represents 10 meters per second squared. And this is the acceleration of any object that is falling in Earth's gravity. And then finally, we have T, that represents time, and that is always in seconds. That's the normal way we do it, time in seconds. Now, if you look at this, we have 10 meters per second squared, and it's times seconds. So one of these seconds will cancel out, and it'll leave us with meters per second. And velocity, as you probably recall, is always in meters per second. So this equation, V equals GT, if you have the variables plugged in right and you're multiplying where you should be multiplying and dividing where you should be dividing, this equation will give you a velocity or a speed in meters per second. So, for example, suppose that we have something in free fall for 3 seconds. Okay? How fast is it going after it's fallen for 3 seconds? So we just plug in the values that we have. So V equals GT. We don't know the speed. That's what we're trying to figure out. So V equals G is always 10 meters per second squared. And in this case, it's times 3 seconds. Now, one of the seconds cancels out, but 10 times 3 equals 30. 30 meters per second. That's how fast something is falling if we let it go and it falls free fall for 3 seconds, 30 meters per second. Now, you may be wondering as you're doing this worksheet, hey, did I get the right answer? Because, okay, I got a number, but great. Is that really the number? So here's a trick you can do. You can confirm your answer by working the problem backwards. Now, what do I mean by that? This question, I said something is in free fall for 3 seconds. So you're given G, 10, and the time, 3 seconds. And from that, you needed to figure out the speed. And you got 30 seconds. But I could also ask the question, hey, something's been in free fall for a while, and it's going 30 meters per second. How much time has it been falling for? How many seconds has it been falling? So you just do the same thing. You set up like this. 30 meters per second, because that's the given speed, is equal to G, which is 10 meters per second squared, times some time. All right? So to get the time, you're going to divide both sides by 10, and you get 3 seconds is equal to the time. So if you take your answer that you got, plug it back into the equation, and solve it for the thing you were given. If you get the thing you were given, 3 seconds, that's what we were given. If you get back to what you were given, then you've probably done it all right. It's also good practice for solving the equations. Okay, so how fast? V equals GT. Now the other one we have is how far. So we drop a ball out the window and we listen, 1001, 1002, 1003, and it hits the ground. How far did it fall? How high was the window above the ground? The equation for this one is D equals 1/2 G times T squared. Okay? Looks a little messy, but there's a shortcut we can do in this one to make it a little bit easier for us. All right, now once again, we want to define the variables so that we have these things. D is distance. That's the distance that it's fallen. That's what we're trying to figure out. 1/2 is just a 1/2. It's always 1/2. G, as you recall, is always 10 meters per second squared, and T is the time. Okay, so that means we have 1/2 times 10 meters per second squared times T, or seconds, I should say, seconds, and that's got to be squared. We have to remember to square the seconds. So if it's for 3 seconds, the thing's been falling for 3 seconds. How far has it gone? We don't know the D, the distance. So it's 1/2 times 10 meters per second squared. Now, here's the shortcut. G is always 10. The 1/2 is always 1/2. So this always boils down to 5 meters per second squared. And then we take 3 seconds, and that's got to be squared. So what this means is we can solve this thing pretty easily by taking our time and square it. So 3 squared is 9, and then we multiply it by 5. And you may be able to do this one in your head. If you need a calculator, that's fine. But 3 squared is 9 times 5 equals 45 meters. And that's our answer. Now, I do want to show you in a moment here, how the units come out in this. We had 10 meters per second squared times seconds squared. So we have seconds squared in the numerator, seconds squared in the denominator. They cancel each other out, and you have left with meters. So that means that the distance is in meters, which is reassuring because distance is always in meters. And that's how we do it. So once again, if you put the numbers into the formula in the right places and you multiply where you're supposed to multiply and square where you're supposed to square, the units will cancel out so that you're left with meters for your distance. Now, once again, if you're not sure about this answer, 45 meters, and you want to check it, you can plug the answer back into the original equation. So in this case, we'd say, okay, we've known it's fallen 45 meters. We know the distance, and we want to find the time because we want to see if we can work back to this 3 seconds that we were given with to start with. Okay, and the way we do that, we'd say 45 meters, because that's the distance, is equal to 1/2 times 10 meters per second squared times T squared. Okay, now we know that this is 5 meters per second squared. And we wind up, so we have to divide both sides by 5. So that gives us 45 divided by 5 is 9 seconds squared is equal to T squared. So now all we have to do is take the square root of 9, and the square root of 9 equals 3, so it's 3 seconds. And again, for square roots, you'll want to use a calculator probably, unless it happens to be a perfect square, which this one does. But for most numbers, you just use the square root key. The square root key is the key in your calculator that, let's draw it a little better, looks like that. Sometimes it's the square root of x, but that's what the square root key is. So you hit 9, square root, and it'll give you 3, and that's it. So if you can work the problem backwards and get the same time that you were given, then you can be pretty sure that you got it right. Okay, so what does this look like on the worksheet? There's an object that's in free fall, and it's released at 0 seconds. So at 0 seconds, it's going 0 meters per second and hasn't gone anywhere, so it's gone 0 meters. This dial here is a speedometer, and we indicate there how fast the thing is going after however much time we're dealing with. And then this is the odometer, which tells you how far the thing has gone in the time that we're interested in. And that's what we need to fill in on these. Okay, so they do the first one for you so you can confirm that you've got your method right. And they were nice enough to give you these equations that I just told you right here on the page. So for example, for 1 second, you'd use, and we want to find the speed. V is G times T. So G is 10 times 1 second is 10 meters per second. So there's a little arrow to the 10 on the speedometer there. For the distance, D equals 1/2 GT squared. 1/2 times G is always 5. times 1 squared is 1. So 5 times 1 is 5, and the thing fell 5 meters. Now, I would like you to show your work out here, the actual numbers that you put into it, and the answer that you get. That's so that, for one thing, I know that you've done it, not just copied it from a friend, but it also, much more importantly, you have a sample of how to solve these questions, these equations. So when we have a test, you know how to work through one because you've got samples right there in front of you. Okay? When you do these, I want you to figure out a speed, like for 2 seconds, and then the distance for 2 seconds. And then go on to 3 and do the speed for 3 seconds, and then the distance for 3 seconds. So alternate back and forth between one equation and the other. You get more practice that way. It sticks in your mind better, and you'll get more out of the exercise. Don't forget to answer these questions here, okay? They're part of it as well. This one here is kind of the summation. It asks you to do the same thing, but for 7 seconds, and you do the math. Anyway, that's it. It's due at the start of class next time. Good luck with this, and we'll see you next time.